type of method is called balancing redox reactions in an acid. And you use this method when H2Os and H plus ions are not present in the original reaction. And it states, it tells you that you are in an acid solution. So, just like before, you assign oxidation numbers and you separate the half reactions. In each half reaction, however, you balance all elements except for the oxygens and hydrogens. Step 3, you balance the O's by adding the equivalent number of waters. Step 4, you balance the number of H's by adding H plus ions on both sides of the equation if necessary. You balance for charge by adding electrons. You multiply all coefficients in one or both half reactions by an integer to get the number of electrons in the two half reactions equal, just like you did in the previous method. Step 7, you add the two half reactions together and cancel out any species that appear on both sides of the net reaction. Step 8, you check the charges in atoms that are balanced. Here's an example, okay? So we have this as an example problem. Notice how there's no H pluses. Notice how there's no waters. And it tells me that it's in an acidic solution, okay? So step 1 is assign oxidation numbers, okay? So when I do that, okay, I know that this goes from plus 6 to plus 3, and C goes from, let's see, this is -2, this is plus 1, this is plus 1, so we have plus 6 minus 2 plus 4, this goes to -2. Okay, and then this goes to -2, -4, 2, plus 4. All right, so moving on, we go ahead and we take a look at these equations here, and we include everything that's in the on the reactant side and on the product side for the half reactions. The second step is to balance the number of O's by adding H2O's. Okay, so I have 7 oxygens on one side and I need 7 H2O's. Okay, same thing with over here. I've got 4 oxygens and therefore on the other side I need 4 oxygens. So I have 1 right here, so therefore I'm going to add 3 waters to it to balance out the number of O's. Step 4 is to balance out the H by adding H pluses. Well, in this case I have 14 H's on this side, so therefore I'm going to add 14 H pluses. And on this side I've got 6 H's there, another 6 there, so therefore I'm going to add 12 H pluses on the other side to balance it out. Balance out the charges by adding electrons. Okay, well I know that on this case this is a reduction because it goes from plus 6 down to plus 3. So I need 6 electrons on the other side because this is a plus 6 charge and this is a plus, let's see, this is a plus 6, so this is a plus 12. So therefore I need 6 electrons on the other side to balance it out. On the other side, I need 12 electrons for the reasons listed above. Okay, so you just go through and assign oxidation numbers and equal out the charge. Multiply all coefficients in one or both half reactions by an integer to get the number of E's in the two half reactions equal. So since I have 12 in this reaction and 6 in the other, I'm going to multiply this reaction by 2 in order to balance out the number of electrons. And when I do that, I get this. Okay? Step 7 is to add the two half reactions together and cancel out any species that appear on both sides. Okay? So in this case, I know that these are going to cancel out. Okay? Waters are going to cancel out, except since they don't have equal numbers, they're just going to subtract from each other. So this becomes an 11. All right? And the H's are going to cancel out. Again, since they're not equal, they're just going to subtract from each other, and we get 16. All right? We add them out, we cancel them out, and we rewrite. And we rewrite, and then we check that to make sure that everything is balanced. Okay, so when you go through, we have 16 H's plus another 6. That's 22. We have 22 O's on this side. Okay, we've got 4 K's, 4 K's. We have 4 CRs. We've got 4 CRs. We've got 14 O's plus another 1, 15. We've got 11 plus 4. That gives me 15 O's. And the number of C's, we have 2 C's and we have 2 C's. So everything is balanced. All right. So the final answer is balanced. That's what you need to ask yourself. So going back and forth, doing the back and forth method, and therefore it's balanced. Last type of method is when you're going to be balancing a redox reaction in a base. Okay, and this is when water and hydroxide are not present in a reaction, and it will tell you you have to balance the reaction in a base. Okay, so you use this method again when there aren't any H2Os and OH present in the original reaction. Step 1, again, you sign oxidation numbers, you separate half reactions. In each half reaction, balance all elements except oxygen and hydrogen. Balance out oxygen by adding waters. Balance hydrogens by adding H pluses. Balance the charge by adding electrons. Multiply all coefficients in one or both half reactions by an integer to get all electrons in the two half reactions equal. Add the two half reactions together and cancel out any species that appear on both sides in that reaction. Identify the number of hydrogens in the acidic answer and add the same number of hydroxide ions to both sides of the equation. If H plus and OH appear on the same side, then they will react to make water. In step 10, cancel out water molecules that appear on both sides of the equation. Okay, so it's similar to the acidic type of reaction, except you are going to do these extra steps here. Okay, so let's do an example problem. Oh, and then the last step is to check and make sure everything's balanced. All right. So here's an example. Notice how it doesn't have any OHs or H2Os, so you know you're going to have to balance it in a base. Okay, and it'll tell you. So first step, assign oxidation numbers and separate into half reactions. So we have this. Here's our oxidation numbers. Step 2. Okay, separate into half reactions. So I have this half reaction and this half reaction. Okay, make sure that these elements again are balanced on both sides of the equation. So I have one C on one side, one C on the other, one N on both sides, Mn on both sides equal each other. Okay, now I'm going to go ahead and balance O's and H's by adding waters and hydrogens. Okay, so step 3, we're going to balance the waters. Balance the O's by adding waters. So since I only have one O on this side, I'm going to add one water on this side. Since I have 4 O's on this side and 2 on this side, I'm going to equate the number of O's by adding just 2 waters. Balance out the number of H's. Okay, so since I have 2 H's on this side, I'm going to add 2 H pluses on this side. Since I have 4 H's on this side, I'm going to add 4 H's on this side. Okay. Next step is to balance for charge. Okay. So when I do that, I'm going to get 2 electrons on the oxidizing half reaction and 3 electrons on the reducing half reaction. And that's done by, again, taking a look at your oxidation numbers and what's happening. Okay? Multiply again to make sure that the charges balance out, the number of electrons balance out. So the first oxidation half reaction, I'm going to multiply by 3. Second, the reduction half reaction, I'll multiply by 2. And I get that is my answer. Alright, notice how the number of electrons will cancel out. Step 7, add the 2 half reactions together and cancel out any species that appear on both sides of the net reaction. So when I add them together, okay, I get that, except this is going to turn into a 1, and this is going to turn into a 2. Okay, so when I add them together, I get that as my answer for step 7. Step 8 is identify the number of protons in the acidic answer and add the same number of hydroxide to both sides of the equation. So, since I have 2 H's here, I'm going to add 2 hydroxides to both sides of the equation. Okay? And then if they appear on both sides of the equation, the H plus and the OH, I'm just going to combine those to make waters. Okay? And then the final step is to cancel out the number of water molecules that appear on both sides of the equation. And so this is going to turn into a 1. And final step is to make sure and check that all charges and atoms are balanced. So we have 3 C's on this side, we've got 3 C's on this side. We have 3 N's on this side, we have 3 N's on this side. We have 2 MN's on this side, we have 2 MN's on this side. We have 8 O's, 9 O's on this side. We've got 4 plus 3 plus 2 gives me 9 O's. We have 2 H's and we have 2 H's, so therefore it is balanced.